Recording is going. Back to this important message. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so eventually we are going to go on to section 4.5 today. But first, I have some questions that people emailed me from 3.7. So I'm going to go over those. And then also I have an important announcement. So as I alluded to yesterday, those of you that have the loose leaf package of the textbook, for whatever reason, it does not include chapter 14. Now, chapter 14 is available as an ebook online as part of your web assigned package. It's in there if you can find it. But I will be emailing each and every one of you the PDF file for chapter 14. So be expecting that sometime this afternoon. And wow, somebody's driving there while she's listening to this. I'm impressed. Okay, anyway, so that will be coming in the email this afternoon. All right. Now, also, even though you're doing the same homework assignments, each of you, if you notice in your web assignments, there are numbers that are in red. Those numbers that are in red might be different for someone else. In other words, 10 different people could have 10 different numbers, even though it's the same type of problem. I'm going to go through and I'm going to do the specific problems that were requested from me. So don't panic if it doesn't look exactly like your particular problem. The red numbers may be different, okay? All right, so we're gonna start off with, this is all from section 3.7, okay? And let's see, this is number 12, okay? And in fact, I might be doing, for instance, I think I'm gonna do 2 different versions of problem 19, but they have different numbers, so we'll get to that. All right, anyway, number 12 says this: 9x minus 7y is greater than 21, okay? So the first thing I'm gonna do is take this inequality and write it as an equation. 9x minus 7y equals 21. Then I'm going to go through and make a table and find 2 ordered pairs. Yesterday, I was using the x and y intercepts. I'm going to continue doing that. That'll always work unless the line actually goes through the origin, as I talked about yesterday. So then you'd have to find an additional point because your 2 intercepts would be the same value. Okay. So if y is 0, we get 9x minus 7y equals, oops, not that. Let me fix that. My bad. Eraser. We're going to put a 0 in there. 9x minus 7 times 0 equals 21. Therefore, 9x minus 0 equals 21. 9x equals 21. Divide by 9, we can reduce that down to 7/3. Okay. Any questions about how I found that ordered pair? All right. Next, let x be 0. 9 times 0 minus 7y equals 21. 0 minus 7y equals 21. Negative 7y equals 21. Divide both sides by negative 7y equals negative 3. So now I have the 2 ordered pairs, okay? I'm going to go over here. I'm going to click on the line until it turns blue. I'm going to plot these 2 points. Now, 7/3 as a mixed number would be 2 1/3. But I can't use a mixed number in my ordered pair. But the reason I'm finding that is to know approximately where it is. So x is 7/3 would be right about there. And then 0, negative 3 is right there. But notice that first point, when I plotted it, even though I wanted 7/3 or 2 1/3, it moved over to number 2 or to 2. So I'm going to go over here and click on that. And I'm going to change this. Again, I can't use a mixed number. I've got to write 7/3. Okay. So now my 2 ordered pairs are correct. Let's go back over here. This does not include equals to. Therefore, this line is not solid, it's dashed. Any questions so far? Okay, so we had to correct the ordered pair. We had to make it a dashed line. Now I need to determine which side of the line to shade. Is it above the line over here or below the line over there? So I'm going to choose a test point. I need to choose a point that is not on the line. 0, 0 is not on the line, so I'm going to use 0, 0. That's always a nice point to choose. I'm going to plug that into the actual inequality that I'm graphing. I only use this to set up to find the points that are on it. Okay. Now, if x is 0 and y is 0, we get 9 times 0 minus 7 times 0 greater than 21. 0 minus 0 greater than 21, 0 greater than 21. This is false. That means that 0, 0 is not part of the solution. Therefore, the solution is on the other side of the dotted line. So I click on fill, okay, and there's my answer. It includes the dashed line or dotted line and shaded below it. Now, I'm not going to click submit answer because I'm using a grid that's not this particular problem. So if I click on it, it's going to say it's wrong, but this would be the correct solution. Any questions about this particular problem? All right, I'm going to clear it. And we'll take a look at number 13, still from section 3.7. This says y is greater than or equal to negative 3x plus 5. So again, I'm going to look at just the equation part. I'm going to make a table, and I'll go ahead and use x and y intercepts. So if y is 0, I get 0 equals negative 3x plus 5. I'm going to add 3x to both sides of the equation. 3x equals 5. Divide by 3, x equals 5/3. If x is 0, y equals negative 3 times 0 plus 5, y equals 5. So I've got my 2 ordered pairs. 5/3. Well, 5/3 is 1 2/3. So x is 1 2/3 is going to be right about there. But again, notice it goes over to 2. And then 0, 5 is there. But I'm going to fix this and make this 5/3. So 5/3, 0 and 0, 5 are correct ordered pairs. Since the inequality includes the equal sign, I'm not going to make it dashed. I'm going to leave it as a solid line. If it includes the equals, it's going to be a solid line. If it doesn't, it's going to be a dashed line. I'm going to go ahead and use 0, 0 again as my test point. And I'm going to plug that back into the original inequality. I get 0 greater than or equal to 5. Whoops, this is false. 0 is not greater than or equal to 5. So 0, 0 is not in the solution set. Therefore, it's on the other side. And there's the answer to that one. Any questions on that before we go on? Okay. This is going to be number 19 from section 3.7. And let's go back over here and clear that out. Okay. X minus 1.3 less than or equal to 0. So I'm going to look at the equivalent equation. or the related equation, x minus 1.3 equals 0. All right, so I'm going to make a table of values. Let's see, if x is 0, and then we'll make y equal to 0. Well, if x is 0, I get 0 minus 1.3 equals 0. So, that doesn't seem to work, does it? There's a problem there. Well, here's the problem, okay? And I talked about this yesterday. So if you need to go back and look again, when an equation only has just an x or just a y, it's going to be either a vertical or a horizontal line. So for instance, this equation solving for x would look like that, x equals 1.3. That is a vertical line passing through 1.3, okay? So that means over here, I've got to choose x values that are 1.3. Oops, that's weird. Now that's not what I wanted. Okay. So 1.3 is right about there. What have I got to do? I've got to go over here and put in 1.3. And here's another one. It's going to be 1.3. And this is going to be 0. I've got to put a different value, sorry. Okay, in other words, when it's in this form, x equals a constant, all your x values are going to be the same value, 1.3, and y is going to be whatever. Any questions about that? All right, so now it's less than or equal to, which means it's going to be a solid line. Which side of the line is it on? Well, if x, let's see here. We've got, let's put in a test point. Let's put in 0, 0 again. Test point. And we'll put in 0, 0 and put that in here. 0 minus 1.3 less than or equal to 0. Is negative 1.3 less than or equal to 0? Yes, it is. So we're over here where the 0, 0 is. And that's our solution. Okay. Any questions on that one? All right. We're going to go on to another question. Actually, what we're doing here is going to reinforce what we're going to be doing today, because today we're basically going to be graphing more than one inequality on the same graph to find out where they overlap. So we're going to be doing the same thing again, but two of them on the same graph. So if you're sitting there going, why is he answering all these questions? Get on with the show. This is the show. Okay. Let's see here. So this is going to be, we're still in section 3.7, and this is going to be number 17. Again, it's a let's see, what is it here? It's y minus x less than 0. Okay. Y minus x is less than 0. So I'm going to look at the related equation. Y minus x equals 0. Okay. Now I'm going to do the old intercepts again. Well, let's see, if y is 0, we get 0 equals 0 minus x equals 0. Negative x equals 0. Divide both sides by -1. X equals 0. Oh, this thing goes to the origin, doesn't it? So I'm going to need to use a different second ordered pair. How about if we let x equal 1? Okay. So then we've got y minus 1 equals 0. Add 1, y equals 1. So basically we've got the 2.00 and 1, 1. Again, at any time, if you're confused about something I'm doing, stop me. I'll go back and try and explain it to you so that you're not lost. 0, 0 and 1, 1. Okay. Now, our original problem does not have an equal sign included, so we're going to make that line a dashed line. Okay. I can't use 0, 0 as a test point because it goes through 0, 0. So how about if we use, let's see, How about 4, 7? So that would be up here, 4, 7. We're going to put that in here. So 7 minus 4 less than 0, 3 less than 0, that's false. So 4, 7 is not a solution, therefore it's on this side, and there's your solution. Okay? Questions there? All right, we'll go on to another one. Still in 3.7. Number 19. Now we did a number 19. This one is very similar. It's x minus 1.1 less than or equal to 0. Okay. We did, I think it was, let's see, what was it? X minus 1.3. We did that a little earlier. So this is going to be very similar. You're going to have x minus 1.1 equals 0. But look, there's only one variable in there. So it's basically going to be x equals 1.1. So let's see here. We'll put in a couple of points and we'll go here and we'll make that 1.1 and we'll make that 1.1. And there's our line. Now it's less than or equal to, so it's going to be a solid line. Okay. So test point, how about 0, 0 again? If we put that in there, 0 minus 1.1 less than or equal to 0, negative 1.1 less than or equal to 0, that's true. So it's going to be over on that side. Okay. And we've got 2 more to go. All right, hang in there. Okay. So now, as I kind of said, I'm doing all of these because it's a good review for what we're going to be doing today. If on a given day I get a whole bunch of questions asked from people, I'll probably contact them and deal with them one-on-one. But just for now, this is fine. So 3.7, number 16, y is less than 4x. Okay, so I'm going to look at y equals 4x. If y is 0, 0 equals 4x, divide by 4, divide by 4, x equals 0. So again, I can't use the x and y intercepts both because I'll get the same ordered pair 0, 0. So how about if we let x equal 1? Y equals 4 times 1, y equals 4. Okay. So over here, 0, 0, 1, 4. This does not include the equal sign, so it's going to be a dashed line. Okay. We're going to use a test point. We can't use 0, 0. Oh, how about, let's see, how about 4? How about 4, 0? Can use that, 4, 0. So we plug that in here. So y is 0, x is 4. That's true. 0 is less than 15. So 4, 0, this point is on the correct side. So there's our solution. And one more, and then we'll go on. Okay, any questions there? Clear it. 3.7, number 18. And this is y is greater than negative 4. Okay. The related equation would be y equals negative 4. Okay, x equals a constant we said was a vertical line. Y equals a constant is a horizontal line. So basically what we're going to get is y is negative 4 no matter what x is. Okay, so we could let x be 0, we could let x be 1. X can be whatever it wants to be because it's not even in the equation. But y is always negative 4. So let's see, y is negative 4, x is 0, x is 1, y is negative 4. There we get that line, horizontal line. Oh, but it just says y is greater than negative 4, so it's got to be dashed. Okay, so now test point. I can use 0, 0 because it's not on that line. If I put that in there, I get 0 greater than -4. That's true. So that means this point 0, 0 is part of the solution. So, and there we have the answer. Okay. Any questions about that one? All right. So now we are going to go on to section 4.5. And section 4.5 is solving systems of linear inequalities. Now, if you took Math 85, back in chapter 4, I think it was, you solved systems of equations graphically, and then you use substitution or elimination. And basically, graphically, what you had was you've got your graph, and maybe that you'd graph one line here and another line there. And the point where they intersect is the solution to the system of equations. Okay. What we're going to be doing now is graphing two inequalities and then finding the solution where those two overlap. So for instance, you might have, let's say, let's go to a different color here. Let's say you've got, one of them is a solid line and it's shaded like that. And then maybe a different one. Let's see here. We'll use blue. A different one looks like this. And it's shaded, let's say, on this side. So then your solution to both of those would be here, where the two overlap. Okay? So we're going to graph two different inequalities on the same grid, and then we'll have to figure out where the shading overlaps. And that is where the solution is, because any point that's in there would be a solution to the blue as well as to the brown. Okay? All right. So let's see here. Okay. This says, wait, I think I want to get back to the color. Okay, I've got it black. That's good. 2x plus y greater than or equal to 3. Okay. But then we have a second one, which is x minus 2y is less than or equal to -1. Okay. So we're going to do the same thing twice. First of all, let's solve the equation or the inequality, excuse me, that's written in black. So I'm going to find the related equation, 2x plus y equals 3. I'm going to make a table. And I'm just going to continue to use the x and y intercepts, except when I find that I can't because the graph goes through the origin. Okay. So if y is 0, I've got 2x plus 0 equals 3. 2x equals 3. X equals 3 halves. Okay. If x is 0, I've got 2 times 0 plus y equals 3. 0 plus y equals 3. Y equals 3. So over here, I'm going to plot, 3 halves 0. Well, 3 halves is 1.5. So I go there. Oh, it doesn't like it. It moves it in there. So I'm going to come back over here and put in 3 halves. Now, if the mixed number or fraction is an exact decimal, I could also put in 1.5, and that would be fine. But if you've got a fraction that comes out to be a repeating decimal or something, you don't want to go that route. So I'm just going to advise we stick with fractions. Okay. Now, going back to the original, this should be solid because it includes equals. So I'm not going to make it dashed. Okay. And I'm going to choose a test point. And I'm going to use 0, 0. And I'm going to plug that test point into the original inequality. 2 times 0 plus 0 greater than or equal to 3. 0 plus 0 greater than or equal to 3. 0 greater than or equal to 3, that's false. So 0, 0 is not a solution, so it's going to be over here. Now, I'm going to make a little chart down here. Oops. It's pretty sensitive. You touch it, it moves to the next screen. And I'm going to show that my solution looks like that. Okay. And some of you are wondering why. You'll see here in a minute. Okay. Now I'm going to go back and do the red inequality. Okay. So I'm going to look at the related equation. I'm going to make a table. I'm going to use the x and y intercepts. If y is 0, I get x minus 2 times 0 equals -1. X minus 0 equals -1. X equals -1. Okay. If x is 0, I get 0 minus 2y equals -1. -2y equals -1. Divide both sides by -2, y equals +1/2. Now, watch what happens when I go and start plotting the second. Oh, look at there. It got rid of the shaded area. That's why I made a note to myself what that first one looked like. You'll see how that's going to play out here in a minute. Okay. -1, 0. And then 0, 1/2. But again, when I go and plot that, it's going to move it where I don't want it. -1, 0, 0, 1/2. And this second line also includes the equal to. So both lines in this case are solid. All right. So let's use a test point to find out where that second one, where the red should be shaded. I wish that I could change the colors over here to make one of them black and one of them red. But if there's a way to do that, I haven't heard about it yet. So you'll just have to bear with me here. We're going to use 0, 0 again. That's going to go into that inequality. 0 minus 2 times 0 less than or equal to -1. 0 minus 0, 0 less than or equal to -1. That's false. So for the second line, which is this one, 0, 0 is not a solution. So I would shade it over there. Okay. So it's going to look like that. All right. So let's get rid of all the fill. Okay. So let's go back and kind of review. The black inequality would be filled here and here, right? If it was just that one, just line 1 or inequality 1. The red would be here and here. So where do those two overlap? They overlap in this piece right there. So there is the final solution. In other words, if I took this and put it over the top of this, you'd have this area here. And I know this isn't a perfect picture of what's there, but you see that that's the solution. That's where the two overlap. Any questions about that? Okay. So this is it. Let's look at some new ones. Let's see here. How about, Let's see. Y is less than or equal to 2x. And let's make this, let's see here, get rid of that spot there. And then pen in color black. X plus y less than 4. All right. So we're going to go back and do the red one first. So same process as before. I'm going to take the inequality and write the related equation. I'm going to find two ordered pairs. If y is 0, 0 equals 2x, divide both sides by 2, x equals 0, which means that this graph goes through the origin. So I'll have to use something other than the, let's see, the y-intercept. So how about if I let x equal 1? So then I've got y equals 2 times 1, y equals 2. Okay, so I've got my 2 points. Again, make sure you don't choose this or this, because then it will tell you it's wrong and you'll wonder why. Oh, another thing I was going to mention, because I'm using the same grid each time, it doesn't run into this, but let me see if I can find one. These are all looking the same. What I've run into, and you very well may run into, so you need to be careful with this, is the scale sometimes is not in 1s. The scale might be in 2s or in 5s. So pay attention to your scale, because you might go plotting thinking that they're 1s and then it's wrong. So again, watch the scale. Okay, none of these have that, but there are some in some of the assignments. Okay, let's see. So we've got 0, 0 and 1, 2. This is y less than or equal to 2x. Again, my ordered pairs are correct. I don't need a dashed line. There we go. Now, my test point, I can't use the origin since it goes through the origin. So test point. How about if we use, how about -6, 3? Okay, so -6, 3. I'm going to plug that into there. So 3 less than or equal to 2 times -6, 3 less than or equal to -12. That is false, because 3 is greater than. So my test point of -6, 3 is false. So it's not over here. It's over here. Okay. So I'm going to draw a little sketch to remind me that it's going to look like that. Okay. Now let's go and do the other inequality, the black one. So I'm going to write the related equation. And I'm going to find two ordered pairs. If y is 0, we get x plus 0 equals 4, x equals 4. If x is 0, we get 0 plus y equals 4, so y equals 4. Oh, okay. So here we go. Again, notice the shading disappeared. 4, 0, and 0, 4. That's 0, 4, 0, 0, 4. Ah, this one is dashed because it doesn't include the equal sign. Okay, so we got that one. Now, let's pick a test point for that line. How about 8, 2? We'll take that point right there. Test point 8, 2. Test point 8, 2. So that's going to go in there. 8 plus 2 less than 4, 10 less than 4, that's false. That's supposed to be the word false, believe it or not. False. So 8, 2 for the dotted line or dashed line was false. So that means we're going to be over on this side. Okay, so in review, the red one, which is this solid line, it would be shaded here and here. The dashed line, the black line that's just dashed, would be shaded here and here. So where do the two overlap? If we take this and we put it over the top of this, it's going to be down in this lower piece right there. So there is the solution. Any questions about that? Oops. All right, we've got time for one more. Let's see here. Let's do this one. We've got x is greater than or equal to -1. And y is greater than -2. Okay. So x greater than or equal to -1. The related equation would be x equals -1. Oh, that's that vertical line. So basically, x is -1. Y can be anything it wants to be. Okay, because x is -1 no matter what. So now x is -1, y is 0, x is -1, y is 2. Again, -1, 0, -1, 2. And that's going to be a solid line because it includes the equal to. All right, test point. I can use 0, 0. If I put 0, 0 in there, I get 0 greater than or equal to -1. Is that true? Yes, it is. So our test point is correct. So fill over there. Okay. So if I push too hard, it goes to the next page. So the black inequality is going to look like that. Okay. Let's go to the red inequality. So y equals -2. That's going to be a horizontal line. And y is going to be -2 no matter what x is. So x could be anything I want it to be. Okay. 0, -2, and 1, -2. 0, -2, 1, -2. Oh, that's going to be a dashed line because it doesn't include equals to. Okay. And let's see, for my test point, I'll use 0, 0. Plugging that in here, I get 0 greater than -2. That's true. Let's see, I should have written true here and over here. This was also true, wasn't it? Yeah, sorry about that. So for this one, it's going to be up here. Okay. So it's going to be above the dashed line. All right. So if I overlap the two, well, let's go back and review here. So for the black vertical line, the fill would be to the right of it. Okay. For the red dashed line, the fill would be above it. So they overlap where this is what, quadrant 1 and then a little bit more. Okay. Any questions about that? All right. So just a reminder of a few things. Okay. I'll be back at 1:15 at a different Zoom ID number for an office hour if you have any questions. I'm recording this. I'll be uploading it to YouTube later on today. It should be there by about 2 o'clock this afternoon. If there's any of you that still haven't created a WebAssign account, you need to get in touch with me, because yesterday's assignment, after tonight, it disappears. After the due date time, it disappears. Anyway, are there any questions before we go? Oh, yes, one more thing. Don't forget to be looking for an email that has chapter 14 in a PDF file. All righty. So I'm going to stop the recording.